All right, so in this video we're going to talk about uh, the lot sizing models, but what happens when you have multiple products or customers. So when you have multiple products or customers, ordering, transportation, receiving costs grow with the variety of products. So what we'll do is we'll just assume that there's a subscript for each product. So DI is the annual demand for product I. And when you're looking at ordering costs, there are usually two types of ordering costs that you incur. One is a fixed ordering cost that is incurred every time an order is placed, irrespective of which item is ordered. And SI is an additional ordering cost incurred when that particular product I is ordered. Now, it might so happen that some products need uh, have higher ordering costs than the others because they might have some government regulations associated with them. They might require other people to weigh in when placing an order. So some orders might be more expensive than other orders. So that's the additional ordering cost that you might potentially incur. There are three approaches. One is each product is ordered independently. So each product has a separate manager. The manager manages each product, and they're not talking to each other at all. And then there is a single product. You can have product managers jointly order every product in each lot. So the second model, so first model is where there's no coordination. The second model is where there might be a single product manager who is combining everything into a single lot. So that's the other extreme. And the third type is where product managers order jointly, but not every order contains every product. That is, each lot contains a small subset. Say, for example, some products might have very high demand, some products might have low demand. So you don't want to order low demand products very often, and you might want to order high demand products very often. So you might not order every time, but you might order sometimes in between. So these are the approach 1 and approach 2 are the two extremes. Approach 3 is in between, and we look at all three types of aggregations. Right. So let's look at the first one. You have multiple products ordered and delivered and independent of each other. Right. So let's say that there are three types of products that Best Buy orders. Three types of products that they order. Let's call them L. They're called Light Pro, Med Pro, and Heavy Pro. Those are the three types of models that they order. Demand for Light Pro is 12,000 units per year. Demand for Medium Pro is Medium Pro is 1,200 per year, and the demand for Heavy Pro is 100 per year. So those are three types of computers. So you have Light Pro is basic computers that everybody uses, then Medium Pro. So there's some knowledge required to use those computers, and Heavy Pro is only for really pro people. So so there is a common ordering cost of 4,000. This is incurred whichever item you order. And there's an item specific ordering cost of 1,000. So you'll notice that even though their demands are different, the ordering costs are the same. The holding cost is still 20% of whatever you pay to buy the item, and the unit costs are also the same. So even though the computers are marketed differently, the price that Best Buy pays to buy the computers, they're all the same. Now what do you, so when, if you are doing them independently, this is like solving three separate EOQ models. So let's do that. So I have all the relevant data up here in this Excel file right here. Oops, sorry. Sorry. Okay, I have the Excel file up here. Make this bigger. Make it easier. So the demand, Light Pro, Medium Pro, and Heavy Pro. These are the common ordering costs. This is product specific ordering cost. The holding cost is the same, 20%, and the unit cost is 500 units per item. So what we can do is we can calculate the optimal order quantity using the EOQ formula. Since we are doing them separately, we can order the EOQ formula. So it's square root of 2 times the demand times S, which is the ordering cost. Now, if you're ordering them separately, you have to pay the total ordering cost. You're not going to pay the common ordering cost, you're also going to pay the product specific ordering cost. So in this case, that will be 4,000 plus 1,000, the total ordering cost. So 2 times D times S over the total holding cost, which is little h, this in parenthesis, little h times c. Probably don't have to put it in parenthesis, but anyway. So it's 2 times s d times s over h, capital H, which is little h times c. So that's the optimal order size, and that is 1095. So what we'll do is, because we are going to get fractional values here, optimal order size cannot be fractional. So what I'll do is I'm going to put a round function around it. We're just going to round it to the closest value. If it's more than 0.5, it'll round up. If it's less than 0.5, it'll round down. This 0 says that I don't want any decimal places. So I'm just going to put the round value at 1095. There you go. So medium pro is 346 and heavy pro is 110. Let's make sure I have the same numbers as them. Yeah, 346 and 110. Yeah, exact same numbers. Okay. I just want to show you how to do the model. So cycle inventory is just half of the optimal inventory. So that's the cycle inventory. There you go. Cycle inventory can have decimals. Don't worry about that. Number of orders, that's D divided by Q star. D divided by Q. So annual demand divided by optimal order quantity. Now this you should absolutely not round. So I'm just going to keep 2 decimals. It doesn't have to be 2 decimals, but I am going to keep 2 decimals. There you go. Medium pro and heavy pro. So the number of orders for medium pro is 3.47. Number of orders for heavy pro is 1.09. So that's what you have. So this is the order quantity. Now this means that you will be, each is ordered separately. Each has their own manager. They're managing them separately. There is no coordination between ordering. So you can calculate the annual ordering cost and holding cost. So we know that the holding cost is the cycle inventory times h times little h times c. So that's the annual holding cost, and an annual ordering cost is d. So number of orders. So we know all the number of orders already. So the number of orders times the ordering cost, which is the common ordering cost in this, plus the product specific ordering cost. There you go. You'll notice that these numbers have to be, in fact, have to be the same, because we did some rounding. They're not exactly the same, but if everything is correct, these numbers actually have to be exactly the same. But they're close enough. It's close enough for us to work with them. And there you go. So again, see, very close to each other. If we didn't round them up and the actual numbers, these numbers would exactly be equal to each other. Okay. That's right. So that's the annual ordering one, and that's how you do it. So the total cost. So let me see. Did they also calculate the annual cost, holding cost, ordering cost? Okay. Yeah, I guess they just added those two numbers. So we are not including the material cost here. We'll just calculate total. Because material cost is fixed, doesn't depend upon order quantity, we can leave that aside for the time being. But when we do quantity discount models later on, we will absolutely talk about that. There you go. The total is the sum of everything. There you go. 155,000 and $155,140. That's essentially what that is. That's total. That's the total cost of ordering and managing them independently. Right now, 155,140. Now, what if they are ordered and delivered jointly? What if instead of doing that, you say, okay, I'm just going to order all of them at once. There is a single manager who's managing everything, doesn't want to think about doing separate orders or anything like that, but order them all at once. Now, why is this useful? This is useful because you're ordering them all at once. That common ordering cost that you had, you would pay that only once, right? Common ordering cost, you pay that only once. S. Otherwise, in all of those other things, we did S plus SL, S plus SM, and S plus SH separately. But here you'll be paying just all of them together at the same time, right? Okay. So how do we calculate that? So we can calculate that using the frequency. So we can calculate the frequency, and then we can, using that, we can calculate the value of Q. So if they are ordered, unjoined, delivered, so this is the other end of the spectrum where you're ordering everything at once and you're doing everything together, right? So let me copy some of this out. If you're ordering and delivering jointly, right? Now what do we do? So what you do here is you're going to calculate a few of these numbers. So first thing that you'll calculate is the total ordering cost. So let's calculate the total ordering cost. So now this sort of boils down to like a single order. So it's almost like you have a single item. You can calculate the total ordering cost. Total ordering cost is the sum of 4,000 and 1,000. So we are not going to pay 4,000 three times. We're just going to pay the 4,000 once, and then you're going to pay 1,000, 1,000, 1,000 separately for each of the three orders. So the total ordering cost will now be $7,000. Now the unit cost is still $500 per unit. The holding cost is still 20%. So that thing doesn't change, right? So 7,000 per order. So we can calculate the frequency of order as demand. So remember the formula for frequency was right here. So it's demand times H times C over 2 times S. But instead of just having demand times H times C, we're going to have demand times H times C for all three products put together. That's exactly what this formula was. It's demand times H times C plus demand times H times C plus demand times H times C for the three items divided by 2 times the fixed ordering cost. That is a single number, right? So let's calculate N star. So it's demand times H times C. So N star, or number of orders, will be square root. It's demand times H times C, and you're adding multiple of them. So it's demand times H times C plus demand times H C plus demand times H times C. So that's demand times C. So all of this is the numerator. So I'm going to put a big parenthesis around all of this. So this is the numerator divided by 2 times the ordering cost. So again, it's demand times H times C, demand times H times C, demand times H times C divided by 2 times the ordering cost, and this should turn out to be something says something. I think it's a matter of parenthesis. Yep. It is a matter of parenthesis right there. Okay. Right. 9.75. Sorry. The number of orders should be 9.75. So we'll be ordering 9.75 times a year approximately, which means that in the 10th order, 75% of the 10th order is part of this year, while 25% of the 10th order will be part of the next year. So that's what you do, total number of orders. So once you have the total number of orders, you can now calculate the rest of the values. So the annual ordering cost will be 9.75 times the 7,000, which will be 68,250. And the annual holding cost, you can calculate that separately for each of the three. And then, of course, you can calculate the total holding cost. So that will come out, you add the annual ordering cost, and that gives you the 136,000. So let's quickly calculate these numbers. So the annual ordering cost is number of orders times the ordering cost, right? So that part is straightforward. The holding cost, this we have to calculate individually for each of these items. So that will be D times, so you can calculate that as D times H times C over 2 times N. So that's one of the ways of calculating that. So it will be D times H times C divided by 2 times the number of orders. Calculate that for the three values. Oh, oops. Calculate that for the three values, and the total cost is the sum of this number and these three numbers. No decimals. So $136,558. So that's what we have. Again, okay, so it's slightly different from that, but it's just the rounding issues. They directly use 9.75 instead of we use the actual number. We don't round it up to 2 decimals. So that's what you have. So this is what happens when you're doing that. So 136,528 when you order all of them and jointly and deliver. So you'll notice that this cost is in fact lower than this cost, which was you're looking at them separately, different from each other, right? And that's because there's a huge saving for when you're doing them separately. You're paying the common ordering cost each time, but here you're only paying the common ordering cost once. But even this is one extreme in the sense that you are ordering almost 10 times a year for an item whose demand is 120. Essentially, you'll be ordering about 12 computers each time you order, or 10 or 11 computers each time you order, which is well, ridiculous in a sense. So you should not be ordering it so often. So maybe it might make sense for us to order, let's say, the light pro computers very often, medium pro computers a medium amount of time, and the high pro computers not so often. And maybe that will give us some more reduction in cost. Maybe that's the case. Let's see if in fact that's the case. So let's look at the third type of model. Here's another example. So it's aggregation with this is a capacity constraint. This model I'm going to leave you to read on your own. It's just a simple extension of the model here. Let's say that if your optimal order quantity is 2,684 units, but let's say you have a truck capacity of 2,500 units, then well, you have to go with the truck capacity. You cannot order 2,684 units. So because there are 4 different products, you'll order 625 of each of those. So you can recalculate your ordering and holding cost based on that. If your order capacity is less than truck capacity, then just order how much. If your order quantity is less than the truck capacity, order your order quantity. If your order quantity is more than the truck capacity, then you order whatever your truck capacity is. That's essentially what that is. Now, the last one we'll talk about is slightly more complicated, which is lots ordered and delivered jointly, but only for a selected subset, right? So what this means is that we will order, so let's say that we have 50 products, right? Oops. Text. Let's say you're ordering 50 products. Now, some of these products you order very often, some of these products you don't order very often. So maybe you order 10 products every time you place an order. Maybe 30 of those products you order half of the time, and maybe 5 or 6 products you order only twice a year or something like that. So can we do that sort of staggering, and how do we figure that out? That how do we do that sort of staggering? So let's take this example here. Like I said, we should not be ordering light pro, medium pro, and heavy pro exactly the same number. So even though this gives us a reduction in cost, it doesn't give us the total reduction that we might potentially get. So what we do is we're going to go through this this model. So there are 5 steps in this model. So we're going to go through these 5 steps and take it from there. So the step number 1 is we'll look at what happens when we order them individually. So we already did this. So this is what happens when you order them one at a time individually without any comparison with each other. We already did that. And the number of orders for light pro is 10.96, medium pro is 3.47, and heavy pro is 1.09. So what we do is, let me say that, well, we are going to identify the product that is ordered the most often. And the product that is ordered the most often is the light pro. So when you do them separately, light pro is ordered 10.96 times a year, almost 11 times a year. So that's what you have. So this I, identify the most frequently ordered items. So for all other products, we evaluate the ordering frequency, right? Now, once you evaluate this ordering frequency, what this will tell us is relative to the most frequently ordered item, how often should we order this item relative to that? So if this is ordered 10 times a year, should we order this every other time this is ordered? Should we order it every 3 times this is ordered? So we are going to calculate that. So to do that, we calculate this n double bar, and we calculate this thing called MI, which is the rounding up. So this is the symbol for rounding up of n bar over n double bar. So we calculate this factor. It's called the frequency factor, and then we recalculate the order quantity for the most frequently ordered item using the values of MI. So we are going to rebalance everything, and once we rebalance everything, then we're going to evaluate the order frequency of each of those individual items and then calculate the total cost. This is called tailored aggregation, right? So let's go through these 5 steps. Now the steps might have looked difficult, or the values might have looked difficult, but it really isn't. So let's go through these steps independent of what we did before. So this tailored aggregation. So I'm going to call it that. Put in parentheses. All right. So first step is to find the value of n bar. So n bar, we calculate this as square root, right, of 2 times d times, this time we're going to do the total s. So we are looking at individual. Like I said, we did this before. 2 times s times d over holding cost times the unit cost. So HC, right? So this is a usual EOQ formula where the total cost is the total order cost. There you go. Oh, right, I'm calculating n bar, so I have to do it the other way around. Calculation of n bar, that will be H times C times D divided by 2 times the total order. I mean, it's just a reworking of the formula. Numerator becomes denominator, D goes to the numerator. It's a simple reworking, nothing fancy. 10.9, just like we had before. So n bar will be 10.9 for the maximum of these three numbers. So let's call this n bar I individual, and then we'll just calculate n bar. Oops, without the I. Just the maximum of these numbers. Right, so that's the value of n bar. So it's the same n bar for all of them. So I just copied everything out. So now we're going to calculate n double bar. Of I. Now this we don't calculate. This we don't calculate for the one that has the highest number. So again, is 2 minutes or some places. Let me just make them 2 decimal places. Okay. So we don't have to calculate that for 10.95. It will be the same. But here it's going to be. So here it is going to be square root. So this time, because we are going to be ordering it with the most frequently ordered item, we don't have to worry about the common ordering cost. It will be just 2 times H times C. I'm sorry, not 2. H times C times D divided by 2 times just the individual ordering cost. Right. So this is where you're saying, if I were to order this along with the other one, how often would that ordering happen? That's why we are not including the common ordering cost. So the common ordering cost is taken care of by the most frequently ordered item. This is for the non-frequently ordered item. Right? Now using this, we're going to calculate the value of mi. So mi, this will be n bar divided by n double bar. Right, now remember, so when you look at the formula for this, there is you see this symbol. This symbol is the rounding up. So we have to put the rounding up formula in here. So this has to be not just divided by that, but round up. So round up is a formula in Excel. It's always going to round up whatever the value, and we want 0 decimals, so it's going to rounding up. So 2 and 5. So we should be ordering medium pro every 2 times we order a light pro, and we should be ordering heavy pro every 5 times that we order a light pro. That's what these numbers are telling us. That's the optimal way to do it. I mean, it's not exactly the optimal way to do it, but it gets very close to the optimal. Now we're going to calculate the actual value of n using this formula here. Right? So the actual value of n number of orders this will be square root. It's going to be a complicated formula, so if you want to chop it up into different pieces, that is an option also. I think that might actually make sense, but I'm just going to put everything into a single formula. This is going to be H times C times M times D D. We're going to add this to So all of this is the numerator. Maybe I'll evaluate the numerator and denominator separately at least. Let me do that. So it's h times c times m times d. You're adding that all up. So that's the, it's not the number of orders. It's the numerator n and then n. Denominator of n is also complex in a formula. This will be 2 times the 4,000, the common ordering cost, plus we're going to do cost divided by mi plus this ordering divided by mi plus this ordering cost divided by mi. It's 2 times s plus s over mi for all the values. That's the numerator, that's the denominator. Now we can calculate the value of n, just n as square root of numerator divided by denominator. There you go. That gives us 11.47. And that is how often you order the most frequently ordered item. So the most frequently ordered item is Light Pro. You should be ordering Light Pro 11.47 times in a year. And how you will be ordering number of orders will be this number divided by mi. So you'll be ordering this 11.47 times in a year, the most commonly ordered item. You'll be ordering this 5.74 times a year, and you'll be ordering this 2.29 times a year. So you'll be ordering this 11.47 times in a year. You'll order this every other time you order this, and you'll order this every 5 times you place an order for this. And that's essentially what you do. So once you have the number of orders, you can calculate the total cost of everything. Right. So once I have the number of orders, so I can calculate the annual ordering cost. So annual ordering cost, so this will be, so you're going to order 11.47 times the common ordering cost. You're going to do that. But to that, you're also going to order this specific, this specific, and this specific. So this is the number of times you're going to incur the common ordering cost. This is the number of times you're going to incur the ordering cost for the Light Pro items, ordering cost for the Medium Pro items, and ordering cost for the Heavy Pro items. Right? And that's the total annual ordering cost. I don't want any decimal places here. And right. And so we can calculate the total holding costs. We can calculate the holding cost separately for the 3 items. So the holding cost, if you remember, the formula for the holding cost was, right. So that'll be D times H times C, divided by 2 times the number of orders, right? The total cost will be sum of all of this. Right. About $130,767. That's total cost. So this is the total cost of tailored aggregation. This is the total cost of just brute force full aggregation. This is the cost of no aggregation. So obviously tailored aggregation is the cheapest option, right? And this is how you aggregate multiple orders. Now, this might seem like I did a lot of stuff and took a very long time. It really shouldn't take a very long time. Because I was looking at formulas back and forth. That's the only reason I took so long. But otherwise, it's there are three methods of aggregation. Three things that you can consider: absolutely no aggregation, full 100% aggregation, or tailored aggregation. As you notice, tailored aggregation is usually the best way to go about it. All right.